Hi, so this video is in Concept 3 in Chapter 11. So this would be 11.3. We're changing from standard form to factored form. So we've done this a lot. So remember, standard form is ax squared plus bx plus c. So this is the form it's going to be given to us in today. We're changing it to factored form, which means we just need to factor it. So we'll have a plus some root 1, a minus root 2, or a plus root 2. So, for example, if I have x squared minus 2x minus 3, factored form would be x minus 3 times x plus 1, right? So x factoring. So here you would use a, which is 1, times c, which is negative 3. So you're looking for two numbers that multiply to negative 3 and add to negative 2, which would be negative 3 and 1. So you can write that as x minus 3 times x plus 1. Remember, you would always divide each of these by a, but when a is 1, it doesn't change them. But just don't forget that step. Okay. So in our example here, the form of the equation in standard form, x squared minus 2x minus 3, is written in factored form as y equals x minus 3 times x plus 1. Now let's look at the graph. So the first thing we want to do here is we want to find the y-intercept of the graph. So remember, anytime you're trying to find the y-intercept, you're going to plug in 0 for x. Okay, so I'm putting that in parentheses here. Plug 0 in for x. You can do it to either form. It doesn't really matter. They're both the same. So let's do it in this first form. That would go to 0. That would go to 0. And we'd just be left with negative 3. So that's where it's going to cross the y-axis. So at negative 3, 0. I'm sorry, at 0, negative 3. Right, the x was 0, the y is negative 3. To find the x-intercepts, we do the same thing, but we replace y with 0 instead of x. So this one, you'll definitely want to use this form when you put y as 0. And then you're solving each of these factors for x. So x is 3 and negative 1. And so basically that's the same as finding the solutions or the zeros of the function. So now if you look at our graph, we have an x-intercept at negative 1, 0, one at 3, 0. We have a y-intercept at 0, negative 3. The solutions to the function, we just found them in the previous step, x equals 3 and x equals negative 1, and zeros is just another name for the same thing. So this is really just pointing out that zeros, solutions, and x-intercepts are three different words for the same thing. Sometimes it just kind of slightly depends on which context you're using it in, but that's what it's referring to if it talks about any of those. All right, so whenever the graph has an x-intercept, that point represents a real zero or a real solution of the quadratic function. So if you see it touching the x-axis, if the zeros or solutions are also x-intercepts on the graph, those are real solutions. Okay. To find a function's x-intercept, set y equal to 0. Change the quadratic into factored form and find the zeros or solve for x. That's what we just did in step 3 above here. Okay, to find functions y-intercept, set x equal to 0 and solve for y. Okay, so you're just putting 0 in where x is and evaluating for y. That gives you the y-intercept. To find a function's vertex, we're going to use the formula for the axis of symmetry we discussed in concept 2. So that's the h equals negative b over 2a, and k is equal to the function evaluated at our h value. And that will give us the vertex, which is at hk. So if we have hk, we have the vertex. Okay, so for each equation, find the x-intercepts, y-intercepts, and the vertex and sketch the graph. So y equals x squared plus 2x minus 15. The x-intercepts are found by putting y equal to 0. And in order to actually solve or find those zeros or those solutions, we need to change this to factored form. A is equal to 1. C is negative 15. 1 times negative 15 is negative 15. B is equal to 2. So I'm looking for two numbers that multiply to negative 15 and add to 2. So that would be 5 and negative 3. So factored form would be x plus 5 times x minus 3. Remember, we're trying to find the y-intercepts, or sorry, the x-intercepts, so we're going to set y equal to 0. So if I set each factor equal to 0 and solve for x, I'm going to get x is equal to negative 5 and x is equal to 3. So negative 5, 0, and 3, 0 are the x-intercepts. Now remember, on each of these, when you're factoring, don't forget you want to divide each of these by a. When a is 1, it won't change it. That's why I didn't bother on that one. But just make sure that you do that step each time. Okay, in order to find the vertex, we're going to use our little formula. We're going to find hk. So h is equal to negative b, so it'd be negative 2 over 2 times a, which is 1. So it's just negative 2 divided by 2, which is negative 1. The x value of the vertex is negative 1. Now to find the y value, we take the x value for the vertex and we plug it in to the function. So we would have negative 1 squared plus 2 times negative 1 minus 15. You could plug it into the factored form as well. That will work, just give you the same answer. So negative 1 squared is 1. 2 times negative 1 would be minus 2, and then minus 15. So that would give me negative 16. So that is the y value of the vertex. All right, and then the y-intercept we find by plugging in 0 for x. So if I put 0 in here and here, I'm just going to be left with negative 15. So when x is 0, y is negative 15. So that's the y-intercept. Okay. So go up to my function here. Let's do each of our squares as 2 because we have some bigger numbers here. So negative 2, negative 4, negative 6, negative 8, negative 10, negative 12, negative 14. So we're going to be even a little bit lower than that. So my y-intercept is going to be here at 0, negative 15. My x-intercepts are at negative 5, 0, and 3, 0. And then my vertex is at negative 1, negative 16. So that would be right in here about, let's see, negative 1, negative 16. And then I would just draw in my U shape here. And that looks terrible, but you get the idea. It should cross right there. So that's what the function would look like. Okay. So let's try the same thing on this next one. We want to find the x-intercepts first by putting this in factored form. Right, so we're going to have x and x. So we're x factoring. A is negative 1 and c is negative 8. Negative 1 and negative 8 makes positive 8. Negative 6 is b. So I'm looking for two numbers that multiply to 8 and add to negative 6. So that would be negative 2 and negative 4. Okay, but then don't forget here our a was negative 1, so we have to divide each of these by negative 1. Now this is a little bit tricky when you get a negative 1 because we had a negative in front of our x. So here what we actually want to do is we want to divide one of these in. So for example, negative 2 divided by negative 1 is positive 2. The other one we want to bring out front, negative 1 minus 4. Instead of dividing it in, we're going to bring it in front of x. Because think about this, when I actually multiply these out, I need to get negative x squared minus 6x minus 8. So let's just make sure that works here. So that'd be negative x squared. That'd be minus 4x, minus 2x, and then minus 8. So my x-intercepts here would be at negative 2, and at negative x minus 4 equals 0, add 4 to both sides. Negative x equals 4, so x equals negative 4. So I would have negative 2, 0, and negative 4, 0. Okay. My vertex, so basically if I would have divided both of these in, I would have still gotten the same zeros. It's just that my form would have looked a little bit different when I multiplied it out. So just be careful if you have a negative in front of x. Just be careful with that. All right, so then the vertex is going to be at negative b over 2a. So negative b would be 6. Negative 6 is 6 over 2 times negative 1. So 6 divided by negative 2 is negative 3. So that's the x value of the vertex. To find the y value, we plug negative 3 in. So this would give me negative 3 squared minus 6 times negative 3 minus 8. So this would be 9 or negative 9. Negative 6 and 3 gives me plus 18 and then minus 8. So negative 9 plus 8 is, negative 9 plus 18 is 9, and 9 minus 1. 9 minus 8 is 1. So negative 3, 1 is the vertex. And the y-intercepts, we find that by plugging in x equals 0. So that's easiest to plug into this form because that will go to 0, that will go to 0. And I'm left with negative 8. So then just plot those things on the graph. Let's do 2's again. So there's my y-intercept. X-intercept, we do 2, 4, 6, 8. Got negative 2, negative 4, negative 6, negative 8. My vertex is at negative 3, 1. It's right there. Oops, no, it's not right there because I did 2's. So it'd be negative 3, 1 will be right here. Goodness, I'm making a mess. And then I would have my x-intercepts at negative 2, 0. And negative 4, 0. And remember that negative means it's opening downward, so it would look like that, my graph. Okay. All right, I think that's all we have on here. I know on your assignment there is one story problem. It gives you a quadratic, much like this one. It's negative in front, so it's going to be turned upside down. And it's saying that y is the height and x is the time. It's asking you at what time y hits the ground. So when it hits the ground, the height would be 0. So again, you're just setting it equal to 0 in the equation, and then you're finding the zeros, and then you'll use the one that makes sense with time, which would be the positive solution. All right, guys, so enjoy your day, and we'll see you next time.